Okay, let me share my screen and we'll get stuck into it. Thank you, Kathy. Module 2. So let's see how we go. So record has been hit and we're going to record it so if people miss it, but also you can replay at any point. All right, well, we had a good session last time, didn't we? Talking generally about road safety and at a fairly philosophical level there, how we approach the management of our road network, you know, what we think about and how we go about that. This one, we're going to refine that and delve into a lot more specifics around the road infrastructure. And we're gonna elaborate more on the kinetic energy thresholds for different crash types. We talked about Usain Bolt running into cars and running into pommel horses and different crash types a bit last module. This module, we're going to go a little bit further with that. Then we're going to identify characteristics of intersections that align highly with safe system principles and characteristics of mid-block locations that align highly with safe system principles. And by mid-blocks, if that's not a term you use, mid-blocks really everything between intersections. Yeah, so the network is made up of intersections and mid-blocks, really. Don't forget to count your wallies, of course. Hopefully you all did that last time and got your quiz answers in. Right, let's talk about intersections. Start with intersections, and I am going to give you a little, I suppose, exercise to do shortly, which will give you an opportunity to also have a stretch and fill up water and stuff, but you'll do a little bit of thinking about some intersection, I suppose, design or form choices. But obviously intersections are that point on the network where there is the ability for vehicles to collide, as you can see there in that photo. But it's also an area where with an elevated risk of runoff road crashes. And the reason for that is the fact that we have this turbulence of vehicles coming in and out and the like. And as a result, vehicles will try to avoid an incident or clip another vehicle or the like and leave the road. So what we do see is that risk of runoff road crashes at intersections goes up significantly. It also happens to be the one place around the network where we do see quite a congregation of point source hazard, fixed hazards, such as, well, signal pedestals, if it's a signalized intersection, but we see power poles a lot. We see often culverts and yeah, different fixed objects. So that runoff road risk is even enhanced a little bit more than that. So when we think of intersection crashes, most people are thinking about that in their mind, but I do want you to think about that lane departure crash as well, and leaving leaving the lane and leaving the road. And of course, we've got, you know, pedestrians crossing. We've got other road user types trying to get through there, cyclists, motorcyclists. So it's quite a hotspot of a place on our network. And I think you're all very aware of that. I just wanted to sort of clarify a few of those things. The Monash University Accident Research Centre came out with a few sort of principles for intersection design for, you know, high alignment with safe system principles. And what we see there is some interesting stuff in the way they're sort of talking about it and thinking about it. Now, you remember at the end of last session, we talked about exposure times likelihood times severity being our formula for risk in a safe system assessment. And we're going to sort of build on that significantly in this module, and your exercise after this module will be heavily focused around those elements of exposure, likelihood, and severity. If we look at these principles, we see, you know, the first thing they're saying is, can we have fewer vehicles? And that's really an exposure factor, isn't it? It's the number of people, the number of vehicles exposed to crashes would be down. Fewer intersections is also sort of in that exposure. If we are able to eliminate intersections, there's less points on the network where that intersection crash is able to happen. And maybe still we're having the vehicles that we're going to use those intersections congregating to another intersection, but we might be able to do more at that intersection for risk reduction. I mean, that's pretty sort of run-of-the-mill transport planning style thinking, is to consolidate in access points and intersections if you can. But we do, across Australia and New Zealand, have a real tendency to provide a hugely free access onto our often arterial road network and higher speed network, where we're having side roads, and driveways and access points. And it's quite, if you're able to reduce the exposure by reducing those, you're in a pretty good, you're getting better alignment with safe system principles. Then we go into this fewer conflict points per intersection. And that is a likelihood factor, okay? So you may, in your brain, be thinking, well, is that not an exposure factor? There's less conflict points. But no, we say if there's still conflict points available at this intersection, we'd call it a reduction in the likelihood. You've made it less likely to crash, less conflict points. If we've eliminated those conflict points by closing the intersection, for example, or something like that, or grade separation, so flyover style stuff, we've changed the exposure. But this is a likelihood reducing factor, along with all those other wonderful things like ensuring good guidance through the intersection, advance warning, clear travel paths, and those sorts of things. But then we get into also this really important one, which is the speeds and angles of crashes that are going to happen at that intersection. And you'll notice I say are going to happen at that intersection, not sort of if they happen, but when they happen, because this is sort of that alteration in mindset. We're going to try and minimize the chance that anybody crashes, but it's still going to happen. So how do we then manage the energy within those biomechanically tolerable levels? And that's that colored chart that we put into last module slides of speeds and crash types. And in this one, we also see that they start talking about angles. 90-degree collision, we're talking around the 50 kilometers an hour for passenger vehicle crashes. Where you can get a bit more angle on that, we know that it can sort of go somewhere between 50 and 70 kilometers per hour. And this kind of goes back to your year 10 or 11 physics, where you cast your mind back and you probably did vectors. And if we're able to have a right angle crash like that, has a certain amount that goes to the environment. But if we're able to get some more angle on that, more of the energy is out to the environment, isn't it? So if we are able to provide that angle, it can happen at a higher speed, and the transfer of energy to the humans involved is less. So we're somewhere in that 50 to 70, let's take 60 as a general, decent speed to start to talk about there. When we add vulnerable road users into the mix, we're looking at 30 kilometer per hour or below to try to really dampen the energy of that to something that is generally tolerable to humans. And if we can't meet these requirements, we're really wanting to alter risk and reduce risk to negligible levels if we possibly can. And I'll talk a little bit more about sort of that sort of stuff in a bit. So we gave you some of the graphs and some of that colored chart last session. I'm putting some more stuff here. We see for car-to-car style crashes. We're seeing pretty much at intersections, we're fairly comfortable with bullet vehicles at 40 kilometers per hour or below. Really, even 50 kilometers per hour or below is ultimate threshold there at 90 degrees. But then 60 kilometers per hour for sort of anything in between that to the head, we know that we can get more speed, which is survivable. And this is using something like XChemX or ChemX, which is the kinetic energy management model. It's sort of We use plug-in speeds, vehicle types, geometry of the intersection that sort of is able to spit out the kinetic energy and tolerance levels. Now, in a safe system assessment, you're not going to be required to go to that level of detail and precision. What we're providing you here with this table and the color chart and those sort of things, that's enough to give you a general sort of indication of how severe these crashes might be, okay? And we're not going to need you to go to that level, but it's just, I suppose you might like to know that there are sort of computer models you can use to generate some of these ideas of forces and biomechanical tolerability. Head-on, rear-end style crashes somewhere around the 70 km/h mark, and really 80 km/h is not feasible unless, I stress unless, it is a delta V. So what I mean by that is if we have a vehicle entering a road that's gathered speed and we have another vehicle coming along here and say, you know, this one's going at 100, let's say, all right, and this one's at 80, as they collide, we know that those sort of speed changes are within tolerable levels because it's the delta V, the change in velocity that we're interested in. So we can operate intersections at higher speeds with acceleration lanes. And of course, you see that on freeways and things all the time. Acceleration ramp or lane, and the point of conflict has a really great angle to it. Hopefully the delta V, the change in speed is comparable. And we know that the first crash there is very, very survivable in terms of an energy transfer. Yes, we've got to think about then secondary crashes and run off road and all those sorts of things, but with, you know, that instantaneous first impact we're thinking about. So we're back to some, you know, physics now, thinking about the physics of it. And, you know, you can for new intersections or existing intersections, you can work out your angles of impact. You don't even need to be this precise. So I can sort of scrub this out and you can sort of do this at a bit of a higher level and say, okay, vehicle coming out of this new proposed intersection, vehicle coming down there, that's about a 90 degrees, somewhere around that. So, you know, the speed for passenger vehicles, we're talking somewhere around the 50 km/h or below is what we'd be aiming for there. On the other side of the road, okay, they're sort of in like that. We've got a bit more angle to it. Okay, we're probably, you know, maybe around the 60 for that side because that's got some more angle. And if that crash happens, I've made it over there. And, you know, this one coming in, oh, that's pretty much a right angle. We'll give that a 50 as well. So, you know, you're able to start to do that broad brush looking at speeds and angles, thinking about passenger vehicles. Of course, if you've got other road users, maybe if, you know, this is a shared path crossing or something like that, you'd be thinking about vehicle speeds through there and the tolerability of the vulnerable road users, pedestrians, cyclists, and the speeds we can tolerate there, and whether we need to slow vehicles at that point as well. So you can see it's starting to become angles, speeds, road users involved in these crashes to give us some real indication of what is tolerable. I talked briefly about secondary crashes, and I'm going to give you an exercise to do very shortly, but secondary crashes and thinking about vehicles, you know, it's pretty rare that you get this very square, very clean right angle crash directly like this. It's more often that, you know, the vehicles have attempted to, you know, avoid and, you know, clipped and maybe hit and all sorts of ways that it's happening, and it's very chaotic. But there are secondary crashes, and we talked about them as run off road. Sometimes they start with a intersection style crash and they run off the road. And we know that, well, the Centre for Automotive Safety Research at the University of Adelaide did a big study of lots of intersection crashes that had secondary crash impact as well. So vehicles leaving the road, hitting poles, culverts, other roadside furniture and the like. And so they replotted all those onto an axis, and you can see sort of the two vehicles there, and the bulk of the crashes are going into, secondary crashes are going into those sorts of areas. Now, did they need to do a big bit of research to tell us that? Probably not. I think you all probably would have come up with a pretty similar conclusion. There are some interesting, anomalies of avoiding and clipping and those sort of things, but yeah, just something to, I suppose, remember in our intersection design and our thinking around risk at intersections. Okay, let's get you doing something, because I know you're all chomping at the bit to use this exposure likelihood times severity, and that's what we're really going to be focusing on here. Well, that's going to be part of what we're going to be focusing on. Let me give you the scenario. Actually, I'll pause before I do that and check in with Cassie to see if there's anything that I need to deal with, because I do want you writing stuff into the chat as I go, and I'll answer things or talk about different topics as we go. Kathy, anything pop up that I need to deal with?
Yes, please. There's a question here about reducing the number of intersections. You talked about this earlier. May lead to increased volume at remaining intersections. So does the overall network exposure stay the same?
Yeah, really good question. And well, in a safe system assessment, we have the ability, we often have pretty good traffic modeling to work from. And so you can actually attribute that and quantify it and utilize that in your scoring. If we've sort of drawn a scope boundary around our safe system assessment, you just make it clear in your assessment that that is what you're dealing with. And if that reduces the traffic volume at that intersection, you're scoring that intersection, you'd probably note that this will distribute traffic to other areas, and it just should be noted around that, but you tend to look sort of just at that intersection if that's the scope of your assessment. The reason for that is kind of like, where do you tend to stop if you go sort of too far out that way? But the principle you're thinking about is really good. Like to close an intersection, then push all the traffic from that one down to another intersection just as bad. Well, overall, we're not getting any benefit up. So yeah, but it's about the scope of your particular assessment. Now, we do have a fact sheet, and I'm jumping way ahead in the course here, of how to deal with sort of projects that have that multiple routes and thinking about multiple intersections and the like. So we'll provide you with some more specific guidance on that in one of the later modules. Good question, though. Thank you.
Thanks, Ken. That's all for now.
Okay, well, let's do a little exercise here, and I'll explain this intersection first, and then I'll tell you what you're going to have to do. So here we go. We've got an arterial road with 21,000 vehicles a day. We'll get 10% heavy vehicles. Speed limit 70 kilometres an hour. We've got a side road here with 1,800 vehicles. It's 50 kilometre per hour default speed limit. We got here like a shared path. This is like a culvert drainage thing. Sort of, water goes in there and sort of spills out into there when there's big rain. What else we got here? We've got a bus stop. You can see there a little, I suppose, Danish offset crossing, or Z crossing, as some people call it. Interesting. I would say that's the wrong way. We like our Z crossings or our Danish offset crossings to face you at traffic like that. That's an aside. That's not the purpose of this exercise. I was just, as I was drawing over it, going, I'd like to see that the other way. You want people to walk in and down, facing traffic or cross face traffic. Anyway, they're probably constrained by this COVID. Anyway, sorry, I have gone on a tangent on that. Anyway, what else can I tell you? Up down the road here, about 2 kilometres, is a set of traffic signals. Up the road about another kilometre is a set of traffic signals, probably 800 metres or something. You can, what else can I tell you? This is a service road, takes vehicles in both directions, really just providing access to a handful of houses. It's got a little exit point up here as well, and there's another opening quite a bit further down. Residential area, school about 400 metres down the road, the side road. I think that's probably about all. I'll tell you in context at this stage. I'll welcome questions as we go, but here's a picture of it from street level. So you can see vehicles coming out there. You can see a bus stop, the bus stop there, which I think I mentioned. It's got lighting. Let's have a look at that from the other end. There we go. There's that shared use path over here. Drainage culvert thing there, and a bit of sort of flood area there. Okay, so that's what we're dealing with. The intersection does have a crash history, and the crash history involves all vehicles crashing, vehicles turning in like that and being struck by vehicles coming through here, and vehicles coming out and being struck by vehicles there, and a more minor incident there. So quite a decent crash history, but you know, we're not always driven by crash history these days. It's not the only way to work out risk. This one has presented itself in crashes. So your exercise here is to redesign, redo this intersection to remove fatal and serious injury crashes forever. Okay, we'll come as close as we possibly can. And you've got a budget of $3 million to do that. Now you might be saying, well, I don't know how much stuff costs. That's okay. I am your cost estimator tool. You can just simply type into the chat cost and then put cost dash of whatever you want. Cost of putting up warning signs, and I'll go $3,000. Putting up some warning signs, you know, of approach to the intersection. Cost of grade separation, flyover, big flyover. I would say $63 million. So anything you want cost estimated, I'll do it instantaneously. So, or if you've got a good idea of the cost yourself, you can you don't need to put the cost in, but you go, I can do that within that budget, no worries. So you've got a budget of $3 million. You can't close the intersection. Now, I know you were thinking back to that Monash University principles, less intersections. We just talked about it and saying, oh, I'll just close off that. That's going to be pretty good for at least those intersection-related crashes. Might want to do some other things, but you know, that's pretty good. Unfortunately, we can't do that. We've done the community consultation, and it's been decided by the minister that absolutely this has to stay open. Not only just open, but all movements have to be available in and out of the intersection onto the main arterial. You can tweak around with the service roads if you want, but you have to be able to turn in from this way, out both directions. Okay. And the third one there, in terms of your constraints, is that you are operating in the current political operational framework that you are currently in. Thus meaning that, you know, if you're proposing something quite radical, you need to sort of give us some indication of how you're going to navigate this through the system. Now, if you're a consultant, okay, well, you're trying to convince your clients and the like and move it up the line and get it out there. So how are you going to sort of help do that? Or if you're in a road authority, how are you going to convince your boss or your the public and the community and the politicians that this is a way to go? So having a think about that if you're doing something that you're really pushing boundaries on. So what I'm going to ask you to do then is pop your ideas into the chat when you get there, get to some ideas. But each time you say something, I want you to tell us whether that influences the exposure or the likelihood or the severity. So if you were to say that sign, I'm going to do a warning sign down here, warning sign, intersection ahead or something. Well, you put warning sign and then just put a little L after it. You type in warning sign, L, and that's saying that will reduce the likelihood of crashes. And we know that a warning sign will do a little bit, in terms of maybe alerting some people to the presence of something. Okay, it gets a little, bit more likelihood reduction if we made it, active. So with some flashing lights or something at different points when it comes out, but it's all likelihood related stuff. So, I don't think that will definitely not eliminate death and serious injury going forward. But that's me using an example. You're probably not going to. But you've got $3 million. That's what we're looking for. Then we want you to just put a few things in there. Tell us if they influence exposure, likelihood, and or severity. So you could be multiple that they're influencing, and then we'll have a chat about it. Okay.
And I've gone ahead and done some Kathy cost estimating for you. Hopefully, I was in the right ballpark. So the ones I were after was traffic signals, and I did that one at $2.5 million.
I like it. Yeah.
Okay.
Yeah. It's well set up for traffic signals. So yeah, not a huge amount of civil work. So yeah, good cost estimating, Kathy.
Thank you. And around about, I've gone 7.8 million.
Yes, I like it. Incredibly good there, Kathy. And that I should clarify, that's a roundabout that meets the Austroads Guides to Road Design Part 4B to meet the design vehicle on this route, it's a B double route. So yeah, good. Okay.
I got a bit stuck on a seagull treatment out of the minor road though.
Yeah, okay. Well, so seagull without signalising it, we are going to go with 1.8 million. And so those who are going, well, what the hell's a seagull? A seagull would be sort of to provide some sort of acceleration lane that way and the turn in there. So then these vehicles sort of come in this way. Yeah, it's going to be a little awkward to do, a little bit of widening, you've got a structure to play with, you got a good deal from a contractor, and yeah, you got 1.8 million. We'll let you do that. It's called a seagull because this thing kind of looks like a seagull, this little island, if you draw it like that, for those who know. Anyway, okay, let's keep ticking along. So if you want cost estimations, let us know.
I'm not sure if this is a cost estimation or a suggestion for recommended treatment, but I'll throw it out there. There's a lot of acronyms in it. A TCS for arterial side road, closed service road to left in, left out, and a SZR.
There's a few acronyms. I'm scratching my head out there, but it's good. Okay. I like it. We will cost that at 500,000. I think it looks pretty. Oh, hang on. SZR. What is SZR? I'm not sure. It's not signalised, is it? That's speed zone review. Thank you. Sorry. course. Good old speed zone review. Yep, I'm sticking to my 500,000. So remember to write in exposure, likelihood, or severity.
And the current speed limit along that arterial road is 70 kilometres, is that right?
Correct. That's what we said. Yep. Oh, it is. Yep. We'll give you a few minutes to have a think about this, jot a few things down. Nice to see lots of people putting it out to everybody. That's nice. Others can look at what other ideas are out there.
And can you tell us what the ASD is like once you've had a sip of water?
So we've got good approach sight distance on all approaches, and the SISD out of the side road is also good. We don't have sight distance issues in any direction. All right. Give it a couple more minutes in case people are pondering things. I'll remove that seagull that I drew on there, I think. Give you another 30 seconds. Maybe have a stretch or fill your water up. Actually, I'll give you a minute. Have a stretch, fill your water up, because I don't think we'll have time for another break after this. So type your last thing in. I'll give you a minute.
There's another question, Ken. Are we allowed to close the centre median but leave the rest of the intersection open?
Well, our requirements, your scope of work was to ensure that vehicles can access in and out in all directions. So if you were to close that off somehow, we'd need some sort of very close by facilities to get them to be able to come back that way, or get in here somehow. I don't know what your plan is, but there'd be something else required. I do like your thinking though. That was it's good principles there. So there's another question there. Is there a particular crash we are treating, or is it proactive? Well, we are trying to eliminate death and serious injury into the future. So there's certainly a good element of proactivity there and thinking holistically. Certainly the whole industry is moving away from that very particular crash specific rectification due to some inherent randomness of crashes that's that is there, that sometimes it manifests in crash clusters particularly, and you can attribute to that, but so often we're seeing very random nature of crashes, and so looking for sort of overarching features that can reduce overall crash risk. But I'll talk a little bit more about that shortly. All right, I think, Kathy, I'm going to get back into it now, and I'm going to just have a little read through, and I have been sort of reading things as they come in, but I'm pretty, first of all, very impressed with the engagement here and the thinking people are doing and the ideas that they're coming up with. And thank you for doing that. And also thank you for popping down exposure or likelihood or severity. That's going to be very helpful as you go to do some safe system assessments, to start getting your head really in that space of what is exposure, what is likelihood, what is severity, which is being influenced, and how do we do that? Okay, so we've got quite a number of people looking at signalization of the intersection. And I'm seeing a bit of variety in what people are saying that influences. Most people are saying likelihood, and that's correct. Some are saying severity as well. And we don't tend to give a set of traffic signals a severity reduction when we're thinking about it. We just say it reduces the chance of the crash. If a crash still happens, the severity will be as it was before. Now, there will be circumstances, obviously, where signals, people have slowed and there's a more minor one, but we're still thinking of the availability of that higher end severity crashes as well. So signals are a likelihood reducing factor. So we've seen there, then we see some people looking at, I suppose a few people sort of wanting to also say that traffic signals may influence the exposure to crashes because we're stopping vehicles, separation in time, so they're not exposed to those crashes. Well, we don't think like that either. We say that the same number of vehicles are going through there, same number of pedestrians are crossing, same number of other vehicles coming out. So the exposure is just those numbers that we're seeing, and that's the same numbers that are exposed. If somebody was to run a red or make a mistake, the crash is still to happen. Now, again, unless your traffic modeling has suggested, putting signals in there is going to attract a whole raft of new vehicles, then your exposure might go up, or, it's going to create a new pedestrian desire line, and we're going to have all these new pedestrians crossing. Your exposure's probably gone up there as well. But at a very sort of simplistic perspective, we just say traffic signals only influence the likelihood of crashes. So we're seeing there some ideas around moving the bus stop to make it in a less complicated area as likelihood, correct, well done. We had some interest in this seagull intersection that was then drawn on for those who don't know. And we were talking about that potentially influencing severity of crashes and maybe likelihood, depending. And that's a really interesting one. And I will pause on that just for a second, because the seagull intersections are this really fascinating sort of safe system anomaly, because what we get is this vehicle coming out here and then crashing with a vehicle down here, right? And I just talked to you about delta V at angles, and that's actually quite a nice crash if you're going to have a crash in terms of those speeds and angles. But the challenge we have is that reduced severity of crash at that point also usually, or in a lot of cases, comes with an increased likelihood of crash due to a merge from the right. And that's a horrible merge because of the challenges of that angle of looking back. Any articulated vehicle finds it hugely challenging because they can't look over their shoulder because they've got a cabin or a shipping crate or something blocking their ability to look back there. Old people cannot turn their heads like that. So, you know, and they're relying solely on mirrors. And so we know that's a pretty challenging one. So what we see is this sort of increase in likelihood as a result of that awkward merge maneuver, decrease in severity. And so where you sort of sit with that. The other thing with this, though, is that you still retain exactly the same entry and exit crash of these ones, which is our sort of one of the high severity bullet vehicle crash types. Now, there is actually, some New Zealanders did this pretty awesome work on seagull intersections, and they came up with the intersection seagull intersection determination tool, or something they call it. And so you can plug in a whole lot of variables and just sort of see whether a seagull would be a sort of appropriate thing with the distances you've got, the vehicle volumes, and a whole lot of other things. So we'll probably be able to dig that out and pop it into Moodle for those interested in seagulls. I personally, not a fan of them at all, but their research did show some scenarios where they can provide some benefit. So what else we got? Okay, some people wanting that left in, left out with U-turn facilities, and that provides some interesting sort of reductions in, I would say, likelihood of crashes. You know, we've still got an intersection there. We've still got the people coming in, turning, or, you know, doing U-turns down here and coming in if you sort of block that. So we kind of still do have the same conflict points. This is a little bit about like what we said. We're sort of moving conflict points up here to potentially different, better scenarios, but still exposure-wise, I'd say sort of the same, maybe reduction in the likelihood of crashes. And severity, well, yeah, maybe, because we've got to sort of turn out there, or we're going to come in there, and so the angles will potentially be better. So I'm liking that, a bit of severity reduction as well. What else do we see? Yes, some acceleration lanes, and then some people talking about, okay, raised intersections, raised crossings. So people are saying some raised thresholds on the side road here. So that's an interesting one. Seeing some raised thresholds on the side road. So that'll slow vehicles approaching, and that's maybe nice. Maybe slow vehicles entering, and maybe stop them taking a last minute dash in there to try and beat traffic and the like. So reduced likelihood, I'd say, by a little bit. They're potentially a bit of reduced severity if there are any pedestrians trying to cross this way. So then some others are sort of saying, well, what about raising that whole intersection? Raised intersection. That's an interesting one, isn't it? Now, I'll tell you what, when I was an engineer starting out my career in the Vic Roads office in the design and planning area, and if I'd suggested raising the intersection on an arterial road with 21,000 vehicles and 10% heavy vehicles and B double route and freight route and bus route, everything like that, I would have been really, you know, told to sit in the corner and think about what I just said, you know, for a while. But it's interesting where we're sort of progressing with that. There's a bit more thinking around that. I'm going to come back to that idea. Okay, I think I'll show some slides that kind of touch on some of this, and then I'll come back to this intersection. I'll show you a few of the things they decided to end up changing. But thank you, wonderful input there from everybody. Really great thinking. Actually, you know, a lot of the thinking I can immediately see we've got some pretty good experience in the room, or people who are sort of thinking quite well. So a lot of people are saying signals, and you'll see me use this little symbol and tick which one it is. Really likelihood. We just talk about likelihood factor. We know there's things that can be done, like fully controlled right turns, that really help reduce the likelihood of crashes even more, getting the most we can out of these traffic signals. So that's we know that they're a proven technique for reducing the likelihood of crashes. This is a heat map of death and serious injury. And I took a little segment of outer Melbourne, sort of growthy areas and outer suburban Melbourne. And, the hotter the spot, the more death and serious injury. So you can see, all of these are signalized intersections. What's going on there, right? And I could take this, I could do the same heat mapping, outer suburban Brisbane, outer suburban Sydney, Adelaide, Hobart, Auckland, you name it, pretty much everybody's got this issue where they have the space and the roads are higher speed and the intersections are signalized because the traffic volumes, have got to that point, they signalize them and the like. And that is where the bulk of our death and serious injury is happening in these areas. And in fact, if you take the top 100 intersections on pretty much any of those cities or states, you take Queensland or Victoria, you'll find that the bulk of the top 100 are signalized intersections. Yet we've got this interesting sort of challenge, I suppose, in our industry. It's that we get to a point and we've signalized, we say, oh, the volumes are high and okay, we've got to take that roundabout out and signalize it to get more traffic volume through. And okay, well, we'll put mast arms on it, maybe speed camera as well. And, and we've got to it's got to be signalized because we've got to, manage the traffic through here and it's better capacity and throughput and everything like that. It's kind of almost like that's got to its ultimate form for that intersection until maybe 20 years, 30 years down the track, it gets 50 years down the track, it's going to get a grade separation and the like. But signals kind of end up being in your urban scenarios the ultimate form. But the death and serious injury is just, it's like we build a new one and we think it's somehow going to be different. And we just know we're building that death and serious injury in there. So it becomes a real sort of challenge to us. So we want to say, well, what else can be done? And then the first thing I suppose to say is, well, does a roundabout perform any better than that? I mean, certainly we know that from a traffic operations perspective of moving vehicles through it, we don't get as much throughput through a roundabout. And some of you are, 10 times the traffic engineer I'll ever be in terms of understanding traffic flow theory and the like. But this is not going to operate as well from a vehicle throughput perspective and saturation and everything like that. But what it does do is it significantly addresses the severity of crashes. And I'll walk you through why that is shortly. But we've got a real severity reduction technique here with a roundabout. Now, like a lot of you probably discounted a roundabout straight away for a number of reasons. One, probably when Kathy told you it's going to cost you $7.8 million, you nearly fell off your seat. Well, that's, it probably would have even been more than that at that side, because you need a huge amount of space to get a roundabout in. A large vehicle needs to be able to come in here and sweep around here and, potentially even make a U-turn. And the space for their trailer and to sweep around is big. And the other thing some of you probably immediately wanted to discount it was, well, it's a major road and you've got a sort of minor side road and a roundabout, better when the flows are kind of balanced. And not sure it's the right form from that perspective. And you probably might be thinking, well, if you put a roundabout and you've got small number of vehicles on coming in this way, and you've got these big flows of vehicles up and down here, well, at one point we're probably going to have vehicles banking all the way back here, and they'll never get out. And or maybe they're getting the run, and then our main drag is clogging up, and all sorts of challenges like that. Maybe some of you said no, but a shared use path. There's a school. We've got pedestrians wanting to cross. We've got cyclists wanting to cross. And roundabouts aren't going to be great for that. And these are all really valid points. There are ways, though, I think we can still think about that roundabout still being an option, and we can think about things like I like to do a bit of metering of a roundabout's always fun. So, you know, put a pedestrian crossing up here a bit, maybe have your pedestrians come up through here, and then you put a, you know, loop down the back here. And then so when the banking of traffic gets to that point, these signals trigger, and you know, some of these get out and they go that way, and some of them get in here and store up. But then, you know, so you can play around with a bit of that. You can get much more sort of life out of roundabouts from a traffic perspective by doing those sorts of things. And maybe we don't need to make them as big as that. Now, this is a very, very different road environment, isn't it? But I do love looking at this one and saying, okay, in the UK, but it's a little, just a bit of paint, isn't it? Okay, a little Splitter Island as well, but a bit of paint. And so a larger vehicle, maybe a service vehicle or something coming through here, could track very easily over the top of it. Okay, so that's good. But then you might say, well, what's the purpose of it? What's the point? What safety benefit are we going to get out of that? We're not getting any deflection. We're not getting, you know, so are we going to get speed reductions and things like that? But the key element of this is that anybody approaching this does not believe they have ultimate priority. Whereas if we have a set of traffic signals and there's a green light, somebody believes they have ultimate priority. If it's a road, you know, and the intersection's got to give way, passively controlled, give way or stop sign on the side road, the main road believes they have absolute priority. I mean, they do under the road, they have absolute priority. Right? But absolute priority comes with lack of attention, continuous high speed, and really there's nothing to disrupt that sort of continual flow of the vehicle. But if we're able to, you know, do this, they all sort of come in there with the impression or the chance that they might have to give way. That's a pretty big win in road safety. And if you get worried about the sort of straight line runs through that and the speed and those sorts of things, you can look to sort of slow vehicles on the approach using raised platforms. You can even then, you know, integrate pedestrian facilities sometimes into these with wonderful sort of raised pedestrian crossings at these points. And I've got lots of examples and designs of that if anybody's interested, but that's becoming a real, it's a real flavor of industry at the moment, is wombat crossings around urban roundabouts like this. It's all the rage. Get on board. Anyway, let's talk a little bit more about roundabouts and how awesome they are from a vehicle to vehicle crash perspective. And yeah, this is road safety engineering 101 really stuff, but roundabouts have less conflict points. These are literally less ways that you can crash at the intersection. Now, you see there's just each dot is a way that you can have that crash. You'll see in here the red dots, the crossing crashes. I mean, they are high severity crashes as well. At signalized intersections or give way controlled, stop controlled, passive controlled intersections, we retain the high severity crash type. We remove that with the roundabout. Now, interestingly, we don't actually give roundabouts a likelihood reduction in a safe system assessment. You'd think we should, because we've got less conflict points, less ways to crash. But we do sort of know just from history of crashes that we have lots of rear end style crashes, minor, very minor, but lots of rear end style crashes. And if they're multi-lane roundabouts, we've got merge type crashes and the like. So we tend to keep it fairly simple and say a roundabout is a severity reduction only intersection form compared to signals or a passively controlled. The crash angle is better. Okay. Back by vectors again. But the crash angle there compared to this one will bounce off. It's much friendlier crash angles in that one. And this one's back to sort of that other point, which is that people drive in all sorts of states of consciousness. They've, worked a double shift or been at their brother's wedding and pulled an all-nighter and then driving home, or they, they had a fight with their partner, and we would love everybody to be alert and really with it and switched on. They're not. There's so much driving going on that's not with it. And, you may have been in that state. You may have driven straight through a red light and you've been through it and gone, did I just run straight through a red light? Or you've probably done that 10 minutes of driving and you don't remember any of it, right? We're not with it half the time driving. And so there are engineering features of the road environment that we can put in that bring people back, right? And a roundabout's particularly effective, or any horizontal or vertical geometric changes. So anything that goes up and down or side to side is a really great way to engage a driver in the driving task. So a roundabout has this wonderful ability for people to, half asleep, zoned out completely, approach it, bang, back to reality, slow down, look around. Amazing wins for road safety. Yet a set of traffic signals is so much less effective than that. Red light, straight through occasionally. So that's a big win. Now, roundabouts come in different forms, really. We've got single lane roundabouts, double lane roundabouts, triple lane roundabouts. This is a bit of interesting research was done. So we've got radius of roundabout, we've got speed through that. Speed's a good proxy on crashes usually, but have a look at single lane roundabout, which is our red line there, and double lane roundabout, small radius. We see pretty high speeds through that, don't we? And it sort of comes down, and once you're in some big roundabouts, we're operating about the same. But a turbo roundabout, and just for your interest probably, but a turbo roundabout is a 2-lane roundabout, but you can get them to operate essentially as safely, or at least with that throughput speed, as a single lane roundabout. And I love the fact that people are trying to nut this out. For those who aren't really familiar with what a turbo roundabout is, it's where you have a 2-lane roundabout. You have a raised separator coming in, and you have a raised separator within the circulating carriageway, and you've got a raised sort of separator out. And so if you want to do a right turn, you've got to get in that right lane, get in there, and you come around and out you go. You want to do a left, you sort of get in that left lane and off you go. But there is no ability to do that sort of straight line through there because there's a raised separator. So the speeds are obviously going to be down. It's nicely channelized, and it's really, quite a neat, effective sort of intersection form. Now, there are not many of these in the Southern Hemisphere. There's a few, but these are from the Netherlands, some Dutch examples, and I flipped the image because they drive on the right. It'd be extra confusing if we try to look at it on a drive on right. Love their sort of, look at that. Look at the bike facilities. We'd probably try and run a bike through that mess if we were doing them in Australia. But anyway, that's a point we're going to talk about next module, pedestrian cyclists, and certainly we'll talk about roundabouts. And this is, I suppose, another one. And there's a couple of things I just love looking at this part. What a great capture of roundabout there, because we've seen there, look, it looks like the truck's pulled out, made this mistake. And we've got the white van there. And then there's a couple of things immediately for me. I go, whoa, look at the angle there. Beautiful. Hey, crash. That's going to be not severe at all. And I know that, because of the angle, but I also know the speeds are going to be low, aren't they? We know the speeds will be low. This is a sort of real radial, the nature of these are kind of radial roundabouts. And so they're coming in and then they're going around. So we know that speed's going to be low. And so this is just wins all around. If this was a standard sort of cross intersection and this truck made mistake, which it's obviously making mistakes, came out, we've got this white van coming through at 70 kilometers an hour or something like that, we're in trouble, aren't we? And I'll show this one, and then I'll see if we've got any comments or questions that have come in. But this one, you look at it and you're just like, wow, and it's a mind blower. But I think, from on ground, it wouldn't be as complicated as it looks. It's another Dutch example, and we had this Dutch engineer that we brought in from the Netherlands to talk about roundabout design for cyclists, because it's cool stuff going on there. And I was showing him this. I said, "Oh, this is fascinating. Like in Australia, like those traffic volumes and the roads, it would be a large signalised intersection, 3 lanes in each direction, running at 70, 80 kilometres per hour." And he just had this look on his face. He was like, well, with raised platforms, with speed control. I'm like, nah, probably wouldn't be. It'd just be a large signalised intersection. He's like, well, what about all the death and serious injury to your community? I could not fathom that you'd possibly run an intersection with these volumes like that. It's like either it's grade separated, or it's something like this, which is going to slow your vehicles down to speeds somewhere within tolerable limits when they stuff up, and certainly getting your bikes out of there and things like that. But we'll talk about that next module. And this is signalised, but look at the land take on this. I mean, it's massive. But the thing is that they're like, well, what is the alternative? Like killing and seriously injuring our community? We can't accept that. We've got to slow them down coming in, improve the crash angles. It's really quite a fascinating, completely different look at how you would operate that these sorts of intersections. Kathy, any comments, questions at this stage? And I do want to show a random thing that I'm going to go a little bit off script with. But anyway.
Well, that's exciting. There is a question about turbo roundabouts. My understanding of a turbo roundabout is it's a smaller single lane roundabout in the centre of through lanes outside, similar to what you see in ACT. What's your thought on this layout?
Yeah, I wouldn't quite call that a turbo roundabout. I'd call that a roundabout with a bypass lane. But there's similar principles because we're trying to channelise and separate some movement. So it's similar principles. We do have a little snippet on turbo roundabouts, and there's a link in there back a bit further. But kind of semantics. I mean, turbos have that separation in the circulating carriageway as well.
I've popped that turbo roundabout snippet in Moodle, so I've been popping a few resources in there as we go that you keep talking about. Thanks, Ken. And another question about U-turns not possible?
No, they are. Oh, hang on, I'll bring that back. Now I'm going to go back, and if we see another Wally, don't count it, people. Yeah, I did this one because I haven't drawn all over it. Yeah, so you want to do a U-turn, you just go into the middle there. There you go.
Okay. Thoughts on a signalised roundabout?
Yeah, I'm okay with signalised roundabout. I like them. I think you're certainly getting really good advantages of the speed reduction, the improved angle, the physical infrastructure in the road to wake people up. You're getting more control with the signals and ability to meter the roundabout, meter your traffic, keep things moving. I know people don't like them for one reason or another, but I think they work pretty well. I'll show you a couple of things in a minute. But I just want to tell you this story. Okay. So I was working at Vic Roads, Victorian Road Authority, and I was in the road safety department. This was a while back, and we had a massive congestion easing program, like Melbourne's biggest ever congestion easing program. I think it was called Keep Melbourne Moving, and it's basically they were trying to take all these massive growth areas out of suburban roads, starting to get hugely congested because they're building massive subdivisions with no public transport or active transport facility or anything like that. Only option was really people to drive, and so they're all driving, and they're all getting clogged up on these roads that were all sort of fairly regional inner road, like outer roads before, and they were, so they're starting to duplicate them, and there were quite a few roundabouts out there and they were discovering that these roundabouts were clogging up and stopping the people moving, and so keep Melbourne moving. The program was essentially ripping out roundabouts and replacing with traffic signals, and some duplications and things, some things like that. So in the road safety department, our job was we get all these designs. So the regions would be coming up with the designs and of roundabout removal replaced with traffic signals, and we were doing sort of tech reviews of them and the like. And so what I think they were expecting was us checking the phasing, the line marking, the appropriateness of mast arms or not, and sight lines, and all of that sort of good technical stuff, which we were doing. But we also decided we'd start putting a memo over the top of each of these. And I kept a copy of it because I think, well, it was a pretty big deal in there for a while, and you'll see why shortly. Kathy, are you seeing that? Hopefully you're seeing that.
Yep, that's all good.
So this is the blank form of one of them. So inter-office memo, and here we go. So road safety. The road safety department has analysed this project as increasing crashes as follows. Project life, 20 years. Number of deaths attributed to this project, 2.3. People in there to remind them we're not just talking about statistics here, these are people. Number of serious injuries attributed to this project, 12.6. Statement of acceptance. The above road trauma is accepted by, and then a space for the regional manager or regional director, they're called regional managers back there, to sign. Now, did anybody sign it? No. Did we get a lot of complaints and the like? Well, absolutely. And the thing is, though, that that analysis is very easy to do. Like, we all know how easy that is. Well, I don't know. I can tell you how easy it is to do. It's a very easy analysis to do. I understand that based on how effective these different treatments are, and we know that from the fact that people do these studies of like 5,000 roundabout installations and before and after, and how effective they are. 5,000 traffic signal installations before and after, how effective they are. And so generally how effective these are going to be. And yes, you need to adjust a little bit by scenario, but in general, that's you can do that very easily. And go berserk about the responsibility of a road authority is to manage many competing demands, and yes, safety is important, but congestion, blah blah blah. Okay, that's fair enough, but let's just have somebody stand up and sign it off and say, yep, okay, we made a conscious decision in managing the road environment to kill some people to move people faster through there. Well, nobody likes it when you paint it in that light. It's the kind of reality of it. And sometimes you need to be pretty in your face to try and get a bit of movement. Anyway, we got told we weren't allowed to write those memos anymore. But what it did do was, did start to generate that questioning, that swell of, is this appropriate? What else can be done? And that's, they're good discussions to have. And thankfully these days, a safe system assessment pretty much does that exact thing, but in a much more palatable, less likely to lose your job kind of way, which is cool. So let's keep jumping forward. Now, somebody was saying sort of signalised roundabouts. Well, this is a pretty cool, I think, signalised roundabout option with even more traffic throughput ability, because you've got your cut through in order to get more throughput from that. Very much retaining a lot of the benefits of a roundabout through the identification of the something there to slow down, to look around, to have to navigate around something. Now, this is a concept. It hasn't been built, but I love the fact that people are now saying, well, without that there, just as a straight, fast, high-speed, wide intersection, death and serious injury is absolutely sure we're going to get death and serious injury. So can we alter, can we change the form of this. And it was exciting that a few of you are thinking, raise safety platforms. Can we do this? And I said it was completely unacceptable 20 years ago, but probably completely unacceptable 10 years ago. But it's starting to become more acceptable that we can start to look for vertical deflection on major arterials. Okay, so a vertical deflection, I mean some raised things, but I don't necessarily mean like your urban speed hump. Okay, so we can adjust the grades of these, the lengths of these, to just sort of dampen speeds, alert people more to the fact that they're going through a conflict point. And that's actually what this intersection was planned for. So they came to the conclusion, many of you did, that traffic signals were like the right thing to do there from a whole lot of different forms, like unbalanced flow, consistency of up the road, down the road signals, you know, different bits and pieces. Cost, for example, being another big one. But they said, well, we know the death and serious injury happening with these signals, and the fact that they're just high speed, and you know they reduce the death and serious injury. But what else can we do? What more can we do? How can we hit up not just the likelihood, but the severity aspects of this? And so I decided, well, what about we slow the vehicles that are doing the damage, the bullet vehicles? And the bullet vehicles are on the main drag in this scenario, aren't they? Well, that one's turning, but you know, they're bullet vehicles. The vehicles coming out of here, they're target vehicles. They're not going to go up to speed enough to do damage to the other vehicles, pedestrians and things we might need to look at. But the vehicles coming in, vehicles going out, they're target vehicles. So ended up, you know, saying, well, we'll just do platforms on these approaches because there's actually no need to raise the whole intersection and disrupt, you know, vehicles turning in and out like that, as long as we can reduce the speed of these bullet vehicles. And anyway, so off they went and they built that. And you notice a few things here: shallow-ish ramp grades, advisory speeds, right? Not regulatory speed limits. And in fact, advisory speeds are so much more palatable to the community than regulatory speeds. So if they took this 70 km/h road and then speed limited it to 50 with a regulatory speed limit, but they put an advisory speed in this, and you know, these vehicles decide how much they slow down, they're less angry. They can't get pinged as well. So, you know, can't be called revenue raising, can it? But we're getting the output we want, with the outcome we want, which is these vehicles going through, and they picked 50 km/h. Why? Because that is the right angle crash threshold speed for passenger vehicles. And that was their predominant sort of crash type or crash involvement road user that they were particularly, you know, was its dominant passenger vehicle use here. Now, yeah, there are bits of pedestrians and they're not meeting those threshold requirements for that. They're reducing the chance of it. But if those happen, they're still going to be severe. So it's not, you know, perfectly aligned with safe system principles, but it's getting better. And, you know, here's another picture of it. You can see there. And here's one I took while doing post-opening road safety audit of the installation. And I love this photo because what we're seeing here, obviously, green lights. Okay. And vehicles slowing down at the conflict point, the risky area. Now, it's so great from the perspective that we reduce risk at the point of risk. Now, people get angry with this. They're like, wow, it's just inefficient. We're slowing all these vehicles down for this minute chance that this thing could happen. And I'm like, well, what about that roundabout on the next road over? Everybody slows down for that. And nobody's jumping up and down about that. It's just that we haven't done this before. And, you know, it's new and it's not quite the way we've been designing and managing and operating traffic signals in the past. But, you know, it seems to be highly effective in reducing speed through the intersection, and some recent evaluation showing the crash reduction and the fact that it's not significantly impacting a whole lot of those traffic engineering metrics around vehicles and throughput and all those other things. But one other advantage, and I will take questions or comments shortly, Kathy. One other cool sort of unexpected advantage of this is it reduced the dilemma zone. And the dilemma zone is, I'm sure you've been in the dilemma zone, when it's a place in time and space where the light goes orange and the driver is in a dilemma as to whether to put the foot down and go or hit the brakes. So I'm sure you've been in the dilemma zone, but the presence of the raised nature here reduces that dilemma zone considerably, because the majority in a whole lot of that area were to stop because they knew they had to navigate over this platform. So that's pretty cool as well. Dilemma zone. Okay, Kathy, any questions, comments?
Plenty of questions, Ken. Thank you. We'll cover off the questions around this, and then we'll go back. Is there advanced warning signs for the raised crossing?
Yes.
Heavy vehicles slow even further, which reduces their kinetic energy to safer levels also, is a comment.
Yeah. And well, that's an interesting one. Yeah, they do reduce their speed even more, and you know, buses are going through there and the like, and they slow down. So yeah, that's right. They're bigger mass vehicles, they're probably slowing a little bit more. I don't have any actual data on that though, but the theory is good.
Okay, now back to roundabouts. Are there any examples of signalised roundabouts in Australia?
Yeah, no, we've got lots in Melbourne. New Zealand's got a few as well, so they're not Australia, obviously. But yeah, no, up around Eltham, Fitzsimmons Lane. Yep, we can provide a few of those for sure.
What about likelihood and severity when you have high volumes of traffic entering from one direction through these different types of roundabouts?
I'm just trying to think. So we sort of take likelihood and severity based on single vehicle. So you've removed that lots of vehicles that you're speaking of, because that's an exposure factor, right? Then we're into likelihood, and you're really basing it on the individual characteristics. So you would be analysing, you know, the way that the roundabout is through its geometry, its signage, its warning, its camber, drainage, lighting, you know, all those characteristics are sort of likelihood factors. The entry speeds and the like, you'd be analysing for severity factors, the presence of vulnerable road users and those sort of things. But I think when you do some, you know, a couple of modules as you start doing some assessments, that'll probably answer itself, that question.
With our Manningham participants are telling us that Fitzsimmons Lane roundabout is being replaced with traffic signals. Ken?
I did, as I said it, I knew that, and I went, yeah, that's probably one that industry sort of failed on getting it to be raised as well. So maybe we need to dust off the old memo and send it into the government on that one.
Good one, Ken. Now, what about, are we accepting fast diamond intersections in Australia?
Well, diverging diamonds or normal diamonds, but well, interesting thing about interchanges is you sort of you eliminate exposure to crashes at the intersection point originally. You introduce a whole lot more sort of intersections. You introduce two intersections at the end of the ramps where the crossing road was, and you've got your merge points. So the merge points are really pretty good. I talked about secondary crash and ensuring length and a whole lot of other things there, but those secondary intersections, the two new intersections you've created, and you know, how those are treated becomes a really important thing. So for those who are sort of confused, you know, you've got an intersection like that, and then you grade separate it, and you off ramps like that. Well, that intersection and that intersection, yeah, less volume, so lower exposure there, but nonetheless. So what we do really want to see is, roundabouts or some quite well dampened speed, those locations, as well as, as I said, you get pretty good there and you've got no exposure at that location. So that's that. Diverging diamond is a whole other different kettle fish, which I don't think we've got time to get into now, but I'm happy to talk to people individually about that if they want.
Thanks, Ken. One last question at this point. When speed reduction measures are introduced, some traffic may possibly divert to other routes to avoid this. Does this mean the exposure also changes?
Yeah, potentially. I mean, in a safe system assessment, you'll see this later, I don't like to get too involved in the tiny alterations in that. Now, if some really good traffic modelers hand me over some altered traffic patterns that show that thousands of vehicles are going to stop using this road and going to start using the back street next to it, well, that's probably enough to enter then into my safe system assessment. But the bulk of the time, it's not. And you will see shortly, and when you do a safe system assessment, there's such large bands for exposure in terms of traffic volumes that it really is not going to make a difference. It is something to have to think about, obviously, and make a comment on, but yeah, it's not, I suppose, sort of big issues that we're seeing in safe system assessments. Okay. Well, this is sorry, Kathy, were there others?
No, you're good to go.
It's good engagement, thank you, and really appreciate people asking questions. Lots of exciting stuff here, and probably lots of people sort of going, oh, I don't know about this. And well, let me sort of give you a bit more assurance that it's not only that one intersection. Now there's lots and lots of them out there. At least in Victoria and New Zealand, they're going pretty nuts with raised intersections, at large signalised intersections. And this is a pretty good example because this was a roundabout, right? This is Dalton Childs Road, for those who know it. Was a roundabout. Roundabouts were getting ripped out. Traffic signals in. Congestion easing program, number 55 or whatever we're at. It's just rip the roundabout out. Traffic signals in, and a safe system assessment was part of this. And the safe system assessment did that job of that memo and said, well, you're making things worse from a road safety perspective by doing this. We suggest you have a look at raised intersection. And, so the process kind of worked there. This road has something like 55,000 vehicles a day, heavy vehicles, buses, emergency routes, so ambulances and fire trucks running up there. This one's got like 30-something thousand. I mean, we're not talking small intersections here, are we? But this is working beautifully, and they've done the 3 intersections down the road on this stretch. They're all going really well. People got really worried about, the installation, the number of risk workshops and this and that had to happen. And, people going, well, hey, people are going to hit it, and dukes of hazard off flying into the, into the houses, and the noise will be unbearable for the residents, and the heavy vehicles, they'll smash up all of the goods they're carrying, and the buses will have people flying off the seats and breaking their hips, and emergency services, this will mean it'll take 2 hours to get to any emergency because they're slowing down it. None of this is playing out. I mean, okay, when there's something new, people are going to really get worried about all of these things, and you work them through, but we've finally got enough now and enough independent evaluations that we can start to be fairly calm and confident to say none of that is going to happen. Rear ends aren't going off the charts, and all that's happening is a calming of speeds through these intersections. There's a little bit more of it. It'd be nice to see that actually as a lower speed of 20 or something, but anyway, that's okay. We're making progress. And there's lots of design guidance. There's the Victorian Design Guidance, Road Design Note 0307 on race safety platforms and intersections. That's a good one. And Austroads is getting on the bandwagon as well. So effectiveness of the implementation of race safety platforms, great report. New Zealand example on the front cover there. And really sort of gets into some of those things we've just been talking about. So I suppose it's not like I'm saying raise safety platforms, must do everywhere and the like. It's just it happens that they do some pretty great jobs of addressing that severity. And that's the important thing, isn't it? We know this does a great job in reducing the likelihood, but we're sitting on a massive residual of death and serious injury that for the last 50 years, we just put our head in the sand and ignored it. We went, well, they broke the law. The red light, it was clearly a red light. The signals were working fine. They ran the red light. They've got to stop running red lights. And we just, at what point do we just stop thinking that we're going to get different outcomes by doing this? Questions, Kathy, before I go to a rural intersection where you would not put a set of traffic signals?
No questions at the moment. Thanks, Ken.
Okay. And I'll be quick on this one because I want to jump through this, show another little bits, pieces, and then I want to give plenty of time to explain the little activity we've got for people to do over the weekend. No, I joke. You won't have to work over the weekend. It's a very short little thing for you to do. This is an intersection. I just use this as another sort of example of a region's determination to address the severity of crashes, not just leave it to the likelihood of crashes. High speed, 100 kilometre per hour road. I think this one's actually 80, but reduced from 100. And this is sort of, the arterial road goes around like that. Not that it matters hugely. I'll come back to the plan. But they, pretty bad crash history at this one as well. And high speeds and lots of bad stuff. And they said, well, obviously a roundabout's going to be what we want. They know the same things that we all know now, and all the benefits of roundabouts, especially areas like this: no pedestrians, next to no cyclists, and vehicle to vehicle stuff. And so anyway, they got their roundabout design done, and the roundabouts, this big, these massive reverse curves coming into it, really, big stuff. And they look at the price tag, and it's ticked over $10 million because of land acquisition, service relocation. This beast is like a telecommunications exchange building, and it's like $1.5 million to move it 20 meters. So the dollars are just mounting up, and they're like, I can't afford this. And so then they start to look at options, and they go, oh well, what about we do some of those other proven treatments we know about, like some site-activated speed limit reductions, a right turn lane, some lighting, chuck some lighting in there. And, we know all those things are going to reduce the chance of crashes, absolutely. And they're all very well proven things to reduce the likelihood of crashes. But again, safe system assessment's done, and safe system assessment just quantifies and actually shows that will reduce the likelihood of crashes and reduce the risk of this intersection. But there's still quite a bit of risk sitting there. And then, re-pushing for some alterations. And this one, they said, well, why so big with these roundabouts? Why so big? And why so these reverse curves on the approach? And I know some of you are probably saying, oh, well, we don't do reverse curves on the approach, because some jurisdictions aren't big fans of reverse curves. Reverse curves are like sort of chicanes, as I was talking about. But they're just to alert, wake people up, slow people down, approaching the roundabout. They said, why not like a really tiny little circulating roundabout? Concrete apron, big concrete apron. And we'll slow vehicles with some raised platforms on the approach. And then we don't need to go reverse curves. And so that was their plan. Don't need to move this beast, don't need to require as much land. They still need to require a bit of land, deviation of this road, a few other things, but, got in well under half the price. And they managed to build that. And I think, again, it's that example of just sort of pushing hard to say, no, we need to reduce the severity of crashes at this location. So you can see the sort of little circulating carriageway there, and big concrete apron. Now, we've just finished a road design note for the Department of Transport on compact roundabouts and how to design them and consider all these features. And it's a huge amount of design consideration. Probably some of you have got many questions around this. So I think we'll make that available to everybody as well, because it does answer a lot of that. Ramp grades and size of different islands and where you make mountable areas and don't, and lighting, and you can't put lights in the middle of the roundabout now, what do you do? And that sort of drainage, and there's lots of stuff to work through, but we'll provide that. But again, I'm just flagging it as this awesome principle, which is, let's not accept just addressing the likelihood of crashes if we can get to the severity of crashes as well. Let's do a little quiz. If poll, remember, you're not being marked on it. True or false? Traffic signals are not safe system. True, false, or unintelligible question, which really means, Ken, stupid question because you haven't given me enough information or context, or I don't know what you're talking about with that question. All right, we better stop that. Let's have a look. What do we say? Most people say false or unintelligible. Now, it was a little bit of a trick question, so I will go with, I probably would have said unintelligible questions because the traffic signals are not the issue. So maybe that's why people went false. I mean, it's not about traffic. It's not the countermeasure itself. It's the context and the speed and the angles and the energy that could be there. So without context around this, it doesn't mean anything. The other thing that's sort of unintelligible about this question is, like, talking about safe system in this binary way, like that is safe system and that is not safe system. It doesn't make much sense either. I mean, we talk about aligning well with safe system principles or not aligning so well with safe system principles. So, I mean, probably okay. If you said true and you had a particular scenario in mind, that was high speed and bad angles, then that could make sense. If you said false because you were thinking, well, no, not about the signals themselves, so that's probably okay or like. So, maybe everybody can be a winner out of that. But I do want to sort of stress to people, like, some people have occasionally gone out of some of these courses and said, we can't do traffic signals ever again because they're not safe systems. I'm like, whoa, misunderstood what we were trying to get across, which was that the principles in a lot of, particular contexts that we still put traffic signals in don't align well with safe system principles. We are put traffic signals in some really well-aligned safe system ways, with speed appropriate and great ways to move different vehicles and pedestrians and cyclists through. So, okay. All right, good stuff. Thank you. So some summary key points in there, which you can look at in your own time. Now, I'll be pretty quick with lane departure because what we can really just say, and we know, is that we have these big, long, fast roads separated by a white line or two white lines. And we've got an edge line, a little bit of sealed shoulder, sometimes if we're lucky. And people leave the road all along these for all sorts of reasons. They fall asleep, they drop their coffee in their lap, they're texting, they're talking to the kids in the back, a kangaroo jumps out in front, you name it. Like, there's just the list goes on and on and on. I mean, falling asleep pretty much up there is the biggest, but anyway. And then you might go, well, it's going to be higher risk. It's like a curve like that. And you go, yeah, it is a little bit higher risk, but the risks along here are pretty high, and along here are pretty high, and all through the center is pretty high. So the reality is we've just got this massive expanse of network that is not well aligned with safe system principles, because when people make mistakes, which they're inevitably going to do, they either run into vehicles coming at them at 100 or 110, which they're traveling at that speed, or they leave the road and they hit a tree, a power pole, a culvert, they roll over. It's all happening at extremely high speeds, and energy is way beyond what we can handle. And we talked a little bit about side impact toll tests and, what are the sides of vehicles able to handle? And we've got those trees and power poles and things like that. And really, we're talking 30 kilometers an hour, maybe 40, and some, high-end, vehicles that you potentially be able to survive, but it's so low compared to the speed we're traveling. And I mean, this is an example of a 60 kilometer per hour crash, or it's predicted at 60 kilometers per hour from the frames, I suppose. The amount of energy being transferred is just absolutely staggering, isn't it? It's huge. We are so far from what we can survive as humans under this, and we know then, okay, well, if we've got these fixed hazards, which are extremely bad in terms of energy transfer to the occupants of the vehicles, when we power poles and trees and the like. Okay, if we can clear those out, right? Can we clear those out? So we've got these more open areas. Amazingly, what we discover is that the casualty crash rate per 100 million VKT comes down. Well, we knew that always, didn't we? Comes down. But look, it flattens out, asymptotes out around that 4.5 or so casualty crashes per 100 million VKT. This is saying that, clearing is good up to a point, but it's not going to get us, too far. Now, back probably 10, 15 years ago, you go, well, that's the best we can do. Well, I mean, that's the best we can do, because what are you going to do? Put a barrier in there, and that's a hazard in its own right. Well, barrier technology has gone off the charts in the last 20 years, and now it's actually safer to have a barrier somewhere around that 4 to 6 meter area than it is to have cleared area beyond that, because of the chance of rollover, going well beyond any of that. And the other point is that we just can't create those clears. I mean, it's hideously expensive. We usually have to take out native vegetation, or underground power poles, or remove power. We just can't do it. It just doesn't happen. But anyway, a few points around that. We know that these cleared areas, free of roadside hazards, isn't necessarily a safe place to be. It is a safer place to be, but it's not necessarily a safe place to be because of those going beyond those distances and rollover crashes. Doesn't give us the highest alignment with safe system principles. Still valid for that sort of 4 to 5 meter is pretty amazing. But continuous barrier systems is what we're going to want to go. So we're not going to be building these types of road environments. And amazing to see some, new billion-dollar road projects around Australia in the last few years. No, not like a long time ago, but a few years. And they duplicate and they build these cross sections of road. There's big, wide median, and we got, clear zone and big shoulders, and they cut the ribbon, they open it up, and a few months later, a car crosses the road, kills a whole family coming the other way. A brand new multi-billion-dollar road, and this is happening. I mean, it boggles the mind. Imagine that. Imagine they do a new train line between, 2 cities in a state, and they open it up, and 3 months in, 5 people die just going about their business. I mean, it would be unbelievable outrage. Yet we're just sort of like, well, they shouldn't have left the road or fallen asleep or whatever they did, right? So anyway, the Austroads guidance has changed. I mean, we know now that we should be doing continuous safety barrier systems where we possibly can. And again, safe system assessments on those billion-dollar projects should be just demanding that. And actually, in reality, a really great case study out of Western Victoria, which showed in the early stages of the planning and the safe system assessment would have saved, millions and millions, if not hundreds of millions of dollars, because it basically said, why are you buying all that land and clearing all those trees and everything like that? That's a safer cross section. That's a way safer cross section, where you have, some distance to an outer barrier, you have a central barrier, distance to an outer barrier. I mean, unless you're planning to, add third lanes in there or something down the track, But we really want to create, for lack of a better term, the bumper bowling of roads, where people can fall asleep and they can drop their coffee in their lap and they can text, and when they leave their lane, they're not going to go into the opposing lane or into trees or roll over in a paddock. Now, we don't want them to text and we don't want them to fall asleep, and we're going to try and stop them doing that. But when they do, that's what we want to start providing. Now, it's going to be hard because it's expensive, but, one step at a time as we go. Anyway, I've got lots of cross sections in there and lots of different bits and pieces, which I'm not going to cover through now. Lots of fun in then the rollout of that and the specifics of the design of the barriers and which barriers you choose and where do you put them and how far do you offset them, and watching the flexion zone and how do you balance off this, and how do you not create these scenarios where the community go berserk, even though the risk is actually quite low. But those are the details of it. But that continuous barrier system on edge, but also ideally on roadside, in centerline, provides wonderfully high alignment with safe system principles. Questions before I get this last little case study, Kathy, and then we jump into Moodle to show the assignment?
No questions at the moment, Ken, so you're good to carry on.
Good. Well, I kind of did jump through the mid-block fairly quickly. And remember, pedestrians, cyclists, motorcyclists are really going to be covered next module in detail, because hugely important road users, and we're going to be thinking about their safety as much. And in a safe system assessment, you have to. I mean, you're forced to analyse and score and rate the safety for pedestrians and cyclists and motorcyclists, as well as passenger vehicles and heavy vehicles. So you're going to get that holistically rounded stuff. So I can just show you potentially another one. And again, I don't want you to take particularly the product as some sort of specific thing that is being touted as safe system as such. It's the thinking and that's in there. So what we've got here is a crash involving an old Ford, and it contained 4 male passengers, and it happened about 2:30 in the morning in Mildura. And I don't think I need to tell you much more of the story. You're probably piecing it all together in your head now, aren't you? They're going very fast. They've been out partying, and this is what, unfortunately, it happens out there. And this is young males, and we see it all the time. And we're going to be working a whole lot in the enforcement, the behavioural change initiatives, the education, and everything to try and reduce this. But what can we do in the road environment to try to slow them down, to try to make it so this can't happen, to try to reduce the severity of incidents do happen? And this was an interesting one, where they came around and they crashed into the utility pole, and the utility pole had one of these things on it, right? And this thing is called a raptor cushion. Now, the sort of brilliance of this is the energy management thinking that's gone into its design. And what we've got here is not just like your goalpost padding, right? Okay. Yes, this has some padding to it, and certainly collapses a bit like that. But it is not connected to the ground or the pole. Okay. And the design of it means that a vehicle that hits it is sort of moved on, and it rotates and rotates and pushes the energy along. Kind of like in when you do martial arts, and they'll tell you to move the energy of the punch on. I've never done martial arts in my life, but I watch movies. So it rotates and moves energy along and helps it dissipate over time rather than that instantaneous stop against the pole. I just think, like, to me, I just go wonderful, safe system aligned thinking, energy management. Yep, okay, mistakes happening, hit the pole and rotate, and off they go. We have some issues with utility providers letting us put these around power call assets often, and anybody who wants to set up a class action on some of that, I'll be happy to get involved and support, but we will carry on with the good thinking that is around that. Let's not do that quiz. Summary points again, because let's have a little bit of a chat about what the task is, Kathy, for their homework. And I can take any questions that have popped in.
Thank you, Ken. Now we have got a question. What is your thoughts on full containment reducing ability to set up traffic control to complete maintenance, i.e. remove dead animals, potholes, etc., leading to potential road safety issues? Where is the balance between road user safety and road worker safety, which are a symbiotic relationship?
It's a really good question, and I have been having, before COVID, was having quite a bit of fun going and talking to maintenance crews with concerns about central and continuous barrier systems and full containment systems and exactly this. And I sort of talk in a general point here, because obviously, you know, it's a very long conversation. But the reality is that we have far, far, far better ability to alter our maintenance practices than we have to alter humans' behaviour out there from the general public in the way they use the road system. Okay, so what we need to do is, in our design, think about so we need to think about this and factor it into our design. How are we going to do this? How are we going to have pullover areas? Where are we going to have gaps so we can run contraflow if we need? What are the maintenance practices? How do we set up standard operating procedures for our maintenance practices to ensure we can undertake this? And how's it going to alter things? What is the increased cost? And are we factoring that increased cost into these projects rather than just going, oh, well, we built this barrier system, good luck maintaining it and maintaining the road and the roadside and everything else you've got to do. So, you know, I think we've got to move beyond the space of we will not alter our maintenance practices and the way we do things. Okay, so we've got to accept that we can change that, and we can change it really successfully. And the maintenance crews that I've worked with and said, this is the plan, right? We can tweak bits and pieces of it, but generally we are putting a barrier system down the middle. We are putting a barrier system on the outside, right? You are smart, awesome people who know your jobs better than anybody else. Under these conditions, how can you do your job safely, and what do we need to provide you? And they're great. I go, okay, well, we'll do this and we'll change this. And okay, we're going to need truck mounted attenuators now to do this. And we go, okay, well, that's all right. Let's talk to the TAC. We'll add that in, you know, condition, can only do these projects if these, and you know, things happen. And we're able to do it. So yeah, I agree that if we just operate under our current maintenance practices and the like, we are going to increase road worker risk. And that's unacceptable. We understand. But if we do, if we start not doing these projects because of that, we leave the huge risk to the travelling public of us not doing anything there. So that's, I suppose, the high level answer to it. And then, yeah, when you get into the details and funding, and it's hard to do things, so they don't get enough money anyway, and all that. Hope that answered a little bit. Okay, we can see your screen, Kathy. I can see Moodle. You're on mute.
Yes, yes, I am. Thank you. We are in Moodle, and I'm in module 2, and I've been busy putting up a number of resources you've talked about today. So I think I captured them all, maybe some bonus ones in there as well, something about seagull intersections, the road design note on compact roundabouts from DOT. I think that's everything.
Yeah, and you've even put in there the Austroads webinar on race safety platforms, which is a good extra hour of race safety platform discussion. So bring that on.
So if people are super keen, you can, yeah. There's your weekend gone. Anyway, let's have a look at the assignment. So you just click onto there and you download the assignment, which here's one I prepared earlier. And it's a Word document. Ken, do you want to take people through that? You can see that okay?
I can. And yes, somebody's mentioned continuing professional development. The hours keep on coming if you want to watch those webinars. You'll fill that up in no time. Okay, so these is probably similar to the way you will see your two big assignments in this course is that you'll get a Word document and we highlight in yellow the areas you need to do stuff. Okay, so you can see there, fill out your name, put your name in, and then you're going to be asked to put a link to a street view or the coordinates of an intersection. And this can be any intersection you want. It could be the intersection out the front of your house, could be the one near work, could be the one you saw on holiday, whatever it is, all right? You take that intersection and give us a link to it, or at least tell us where it is so we can have a look at it too via our street view. Then the next thing you're going to do is inspect it in quotation marks there, because you can do it all by street view for this one, right? Because this is just a little practice exercise. And then we want you to fill out all the information in this table. Okay, and so what we want you to do is first of all start thinking about exposure to crashes. Okay, and we want you to come up with between 1 and 3 factors that increase exposure at that intersection you're looking at. Now remember, exposure is all about the number of vehicles, the number of people crossing, the number of cyclists going through. So you might say it's a popular recreational cycle route, influencing the number of cyclists, thus that's the exposure of the cyclists, right? But you just say, popular recreational motorcycle or cycling, motorcycle route, or it's a major arterial, or there's a big shopping center there and the desire line to the bus stop is directly across this intersection. Something like that. Something that's going to influence the number of people exposed to crashes, be that in vehicles or on bikes or whatever. And 1 to 3. All right, we don't want more than 3, and we don't want big, like wordy paragraphs, because I don't want to have to read all that. I just want some dot points. Okay, then the likelihood. Then you're going to go, right, okay, that's the exposure. The likelihood. What are some things that are influencing the likelihood of crashes? So increasing the likelihood of crashes. Now, this could be, the signs are faded, it's confusing, the sight distance is blocked, it's got poor lighting, whatever you decide by looking at this intersection and analysing it. And the road safety auditors in the group are, this is where you have a field day. You've got thousands of things. Just give us 1 to 3, right? Then the severity. Okay, what is 1 to 3 things that's going to influence the severity of crashes? And you only have a handful of things to possibly work from here, don't you? Because we know it's speed, it's angle, it's vulnerability of road users involved. I mean, they're the sort of, that's about it. You might go, oh my God, well, everybody here looks like they're over 80 years old. So their frailty is going to be a severity factor. And that, you could put that in there, but the big ones are obviously, speed, angles, road user protection and the like. So you're going to list 1 to 3 there. So you'll get this good idea of the existing conditions. And then we just want only one change that you could make that would influence the exposure, the likelihood, and the severity. Okay, just one thing. And this time I'm not limiting you on budget, politics, on anything, literally whatever you want. Because the purpose of this assignment is that we need to check that you can categorize things into exposure, likelihood, and severity. That is what we need to make sure before we send you out to do a big safe system assessment. So can you categorize things correctly? Exposure, likelihood, and severity. We do it we want to see the intersection as well to just check you're thinking in the sort of right way, but that's the secondary aspect of this. Can you categorize things? Do you have your head around that categorization? Any questions on the assignment? Oh, I suppose when's it due, Kathy?
Yeah, that's a good question, Ken. That should say here when it's due. I'll fix that up. But before next session, so let's say Monday afternoon.
Is that not it there? Oh no, 20th of Jan. No, it's different.
No, that's when it was loaded. That's something different. I need to jump in there and pop a due date in there. But Monday afternoon, 5 p.m. ish, depending on which time zone you're in, before the next session on Tuesday.
Yeah, so the next session we will start with I'll have a bit of a look through the assignments, try and see if there's any common themes people are getting wrong, have a bit of a discussion about that. We'll probably see if one of you wants to volunteer to unmute yourself, talk us through your intersection and your assessment. And so it should be good. But of course, if you have any trouble, if you're sitting there at the moment going, oh my God, I don't understand any of this, get in contact with us. All right, we're here to help. We'll organize a one-on-one catch-up, Zoom call, phone call. We can write you, talk your work, help you through it. It shouldn't take you more than sort of like 10 to 15 minutes at most. Just quickly, Street View, grab it, the factors, design lines and whatever, and pop some dot points in, PDF it, and pop it in there, submit it. And what have you got there? Quiz.
And the quiz
as well.
Yeah, just quick quiz. So if we finish 3 minutes early, then people have got a bonus 3 minutes to do the quiz. Another quiz. And just about everyone's jumped in and done the first one. So thank you. I think everyone's got the hang of it. But if you have any troubles, just send me an email.
Awesome.
Any last questions?
I think they're just excited to get into the quiz and then their little categorizing assignment. Thanks, everybody. Have a wonderful weekend. Log in a little early. Chance to win more prizes with Kathy Super Trivia. And we'll see you next week.
Thanks, everyone. Bye.